Okay, so we need to do a little bit of work on two types of related rate problems that you have for homework. And one is called the sliding ladder. And the other one is called the moving shadow. I think I'm going to wait on the moving shadow for tomorrow in class, but let's go ahead and do the sliding ladder. All right, so I'm in your book. I am on page 27. Okay. All right, a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when its base is 7 feet, 15 feet, 24 feet from the wall? So we really got three problems in one. All right, so let's start by constructing our figure. And the ladder is 25 feet long. And notice this gives us our relationship already. It gives us a nice right triangle. So let's call this side y and this side x, because this is kind of keeping in line with what the x-axis and y-axis be like. They give us that the ladder is sliding out from the wall, so this end is going in this direction. That is a positive direction. The top of the ladder then is falling down the wall, and that is a negative direction, so keep that in mind. We've got the rate of change of x, the bottom of the ladder, with respect to time, is 2 feet per second. All right, so now then we got to make an equation, make a relationship, and we got a nice right triangle, x squared plus y squared equals 25. And I'm going to do the derivative with respect to time. So that's 2x dx dt plus 2y dy dt equals 0. And I want to know how quickly the top of the ladder is sliding down the wall. How fast is the top of the ladder moving down the wall? So that means I'm going to solve for dy dt. So that gives me 2y dy dt, negative 2x dx dt, and dy dt equals negative x over y dx dt. Just a little bit of algebra. Okay, this is the rate of change at the top of the ladder coming down the wall. Notice that your value should be negative because the top of the ladder is sliding down in the negative direction. Okay, so now then I've got to know when this is happening. When the base is 7 feet, the base is the x value. So when x equals 7, now remember, sometimes you have to go back and use the original equation. If x is 7, then y is a value at that point also. So let's get our nice right triangle in here. 25 and the base is 7. What would y be? Well, remember your Pythagorean triples. This will be a 7, 24, 25 triangle. So dy dt be negative 7 over 24, and the value of dx dt is 2 feet per second. So negative 7/12 feet per second. All right, I'm going to just get a new piece of paper, sketch another right triangle. This time I want to know when the ladder is 15. So 25 and 15. Notice these have a common factor of 5. This is a multiple of 5, and this is a multiple of 3 by a factor of 5. So this has to be a 3, 4, 5 triangle, so the length of this side has to be 20. So dy dt equals negative x over y dx dt. So dy dt equals negative 15 over 20 times 2 feet per second. And let's simplify that expression. So negative 3/4 times 2. So dy dt equals negative 3/2 feet per second. Moving a little bit faster. Okay. Then my next one asks for when the ladder is 24 feet from the wall. If that's 24, that has to be 7. So I know you can finish this one without me helping you on that. All right. Then that's part A. Let's go to part B. Consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. Okay, so let's go back. And 25. And then I know this is still moving out at 2 feet per second. This is my x and this is my y. But this time I want to know how the area is changing. So area is 1/2 base times height. All right, so then we want to see if there's any way we can make a relationship to get x and y equal. Can't get any similar triangles going here, so we're just have to go with it. We're going to have to differentiate respect to time, and we're going to have to use the product rule. So here we go. d dt A equals d dt. Let's just 1/2 x times y. Let's put the 1/2 with the x. All right. So the rate of change of the area with respect to time is first times the derivative of the second plus the second times the derivative of the first. Okay, and then we want to look at how the area is changing when the base is 7 feet from the wall. All right, so when the base is 7 feet from the wall, the top of the ladder is 24 feet up from the bottom of the building from here. This length is 24. And going back to our previous work, when x is 7 and y is 24, then the rate of change at the top of the ladder is negative 7/12 feet per second. So dy dt is negative 7/12. So we had to go back and get some information from part A. So here we go. So dA dt, rate of change of area with respect to time, is 1/2 7 negative 7/12 plus the value of y, 24 times 1/2, and dx dt we already know is 2. And we'll put the dimensions in a minute. I just didn't leave enough room to write them. Okay, so this is negative 49 over 24 plus 24, and that will be, need to get a calculator out. So 24 times 24 is negative 49 plus 576 over 24. So this will be feet squared per minute, feet squared per minute, and feet squared per minute. Or is it second? Excuse me. So 527 square feet per second. Okay, so one, we had to just use some information in the problem, go back and find values of x and y. And in part B, we had to go and use something from a previous part of the problem. All right, go to C. And the rate at which the angle between the ladder and the wall of the house, angle between the ladder and the wall of the house, ladder and what, so that's your theta, is changing when the base of the ladder is 7 feet from the wall. So this is my x, this is my y, this is my 25, and we want to relate, the only value we have is dx dt, the rate of change of dx dt. You can use dy dt, but specifically when x is equal to 7. So first of all, let's get a trig relationship going, and I'm going to use opposite over hypotenuse. Opposite of hypotenuse is going to be sine. So sine of theta equals x over 25. Because I want the rate of change of x, I'm going to take the derivative with respect to time. So derivative of sine is cosine, and this will be 1 over 25 dx dt. And so the cosine of theta, all right, so the cosine of theta, let's just go ahead and write it in terms of this problem right here. When x is 7 and this is 24, So cosine of theta would be 24 over 25. And dx dt, ooh, I forgot my d theta dt right here, sorry. And dx dt, we know it's 2. So the angle is changing at 2 over 25 times 25 over 24. And simplifying that expression, the 25's drop out and go 1 over 24, 1 over 12 radians per second. A little bit of a challenging problem. We'll work on the moving shadow tomorrow during class and a few other things to help us study for our quiz.